Hello, everyone. Let's continue with the carbon and its compounds part 2. Okay, this is Harita Kasturi. This is from Hyderabad team, PACE IIT and Medical, right? So today, let us discuss about this carbon and its compounds, the part 2, wherein in part 1, what is that we have done? We have done alkanes, alkenes, alkynes, their reactions, then types of bonding, the single bonds, double bonds, and triple bonds, the allotropes, all these things have been completed. Now we are going up with the next phase of it, which is your functional groups, the mainly functional groups. So we have a few functional groups here to talk about, important functional groups for your 10th grade. So these are your alcohols, aldehydes, carboxylic acids, and ketones, as I'm showing you here. Alcohols, the general formula is CnH2n plus 1OH. Then aldehydes is CnH2nO, carboxylic acid CnH2nO2, and ketones CnH2nO. So let us do what it is all now. So you have already seen alkanes, alkenes, alkynes, right? So now let us deal with alcohols, the functional groups. So here, as you can see, the first functional group, what we talk about is alcohols. Please write it down, bacha. Functional groups, alcohols. Alcohols, the suffix would be your all here. Alcohol, it is all, and it is CnH2n plus 1 with an OH there. It is just nothing but alkane. Okay. It is an alkane. As you can see, this is alkane. This is CH4 is an alkane. You remove this and put an OH there. It means it is CH3OH. Okay. Now I take 2 carbons alkane. This is my 2 carbons alkane. Rest of all are also hydrogens. But now what I do, I remove this. I put an OH here. Then CH3, CH2, OH. This is your alcohol, right? So two carbons alcohol, 1 carbon alcohol, 2 carbons alcohol. So alcohol is nothing but you write an alkane, remove 1 hydrogen, and then put OH block there, right? So that is your representation of an alcohol. Now, as you can see, CnH2n plus 1 OH is your general formula. And let us write down N equals to 1 there. It is 1 carbon with OH group. Now, OH, many people feel that OH is one single thing. No, it is some O single bond H, because oxygen coming at number 8 in the periodic table written as 2, 6, it needs 2 electrons, right? As it needs 2 electrons, it is sharing also 2 electrons, one with carbon, one with oxygen, right? So that is how it goes with 2 bonds. Oxygen is going with 2 bonds, perfect. Hydrogen is going with 1 bond, perfect. Carbon with 3 bonds, because the rest of the things here are hydrogen only, right? This is CH3OH, or just I can write it as CH3OH. Now, as I told you, if N equals to 1, that would be your meth, and this is methanol. It is an alcohol, methanol. And then let's go with N equals to 2 there. N equals to 2. It is 2 carbons and put an OH there. O single bond H you put, or an OH directly, it is fine. Anything is fine. So OH, so now CH2 here, here H, and here again 3 hydrogens, right? So which means it is how much? It is C2H5, all this is 5, right? All this hydrogens, you have 5 hydrogens with OH. Or I can just write it as CH3, CH2, OH. This is your structural formula as you show the orientation of each of the carbons there. That is orientation shown of each of the carbons. It is CH3, CH2, OH, which is ether. N equals to 2 it is, right? So 2 carbons, ether, ethanol, alcohol, right? Ethanol. Then N equals to 3. Let's go with N equals to 3. It is 3 carbons. 1, 2, 3. 3 carbons with the OH. Now you fill it up. 2 here, 2 here, and 3 here. I hope you are able to fill up those hydrogens there. Each carbon should be having 4 bonds all over. So 4 bonds. So here 1 OH here. So 2 more there. Then 2 more. Then 3 there. So which is CH3, CH2, CH2, OH. Each of the carbons oriented in this manner. This would be your 3 carbons and OH. That would be your prop propanol, propane and alcohol, propanol, it is propanol, right? So this is your direct alcohols, what you can do. And let me give you some questions based on this now and try to gauge the questions, the names for them. To try to gauge the names for this, I'm giving you one name here. Yeah. So this is 1, 2, 3, and here I put an OH. Okay, so let us first fill it up, fill the hydrogens there. So this carbon has to get 3 hydrogens, and this carbon has already 3 bonds all over. It wants one more bond only, it is 4. And this last carbon here has got only one carbon there, one bond there, so 3 bonds there. So now this is CH3, then CHOH, and then CH3, right? This is how I represent the 3 of them. Now, what is the name of it? See, or if you write on the molecular formula, what is that? That is C3. How many hydrogens do we have there? 1, 2, 3, 4, 5, 6, 7, and 8. So how many do we have? So here, just count them up and then tell me 1, 2, 3, 4, 5, 6, 7. H7 with OH. So this is definitely your C3H7OH. And then the same molecular formula, C3H7OH. Here also it is C3H7OH only, C3H7OH. But what is the difference between these two? These two are isomers. What do you mean by isomers? Isomers are nothing but same molecular formula but different structural formula. This is a 2-degree alcohol. This is called as 2-degree alcohol. And why is it 2-degree alcohol? Or the IUPAC name, if I have to talk about, identify the main chain. 1, 2, 3. This is your main chain. Wherein second position has got an alcohol. This is propan 2-ol. On the second position, you have an alcohol. So therefore, it is a propan 2-ol there, right? Or this is called as 2-degree alcohol. Why? Because the alcohol which is on the carbon is directly connected to 2 more carbons there. So hence it is your 2-degree alcohol. So try writing, if you can write up for your butane, butanol, then your pentanol. Please keep writing, pause it up and keep writing. Next. Coming up with your 4 alcohols, like, N equals to 4. 1, 2, 3, 4. Here, if I put an OH, then what? 1, 2, 3, 1, 1, 2, 1, 2, 3. So this is nothing but CH3, CH2, CHOH, OH bracket mein, and then CH3, right? This is the orientation for each of the carbons here, as you can see your carbons there. Now this is what? This is butan 2-ol, because now you have to number them also. I will show you the backward numbering here is part of it. Why? Because backward numbering, because the functional group should be your preferred group. And what do you mean by preference? Assigning the least number to it. So this is 1, 2, 3, 4. You have to number only the carbons, not the hydrogens. So number the carbons 1, 2, 3, 4, right? So this is on the second carbon, we have an alcohol, OH group. Therefore, it is butan 2-ol. Now, tell me in that case, this one is going to be what? Yeah, 1, 2, 3, 4. Now, what is this? What is this? Is that the forward numbering? First, identify the main chain. Yes, this is my main chain. Now, is that going to be my forward numbering or backward numbering? If it is my forward numbering, it has to be what? 1, 2, 3, and 4. If I go backward numbering, 1, 2, 3, 4, right? So 3, see, it is 1, 2, 3, 4, you get, right? But then it should be my third carbon on my left. So it is not the one. So forward numbering is correct for this, because the minimum number preference should be given to the functional group. And when you go forward numbering, it will be on the second. If you go backward, it is on the third. Easily, it is on the second only. It is just as good as showing my pen like this once and showing like this once. That's it. It is the same compound. I'm just showing my twisting my pen. That's it here. Okay, so this is about your alcohols. And now coming up with the second functional group, aldehydes. aldehydes. Now, what do we mean by aldehyde? This is CnH2nO. CnH2nO is the next compound, aldehyde, which has got this group CHO. CHO. See, oxygen should have 2 bonds, satisfied. Carbon should have 3 bonds, satisfied. And I put this as RCHO. Now, what does this R stands for? R is an alkyl group. And what is alkyl group? Alkyl is nothing but alkane minus 1 hydrogen. That's it, is my alkyl group, which means if I say CH4, then C2H6, then C3H8, then C4H10, all these are my alkanes, right? Alkane minus hydrogen, which means CH3, here it is C2H5, here it is C3H7, here it is C4H9. These are methyls, alkyl, na? Methyl, this is ethyl, and this is propyl, and this is butyl, pentyl, hexyl, heptyl. It goes on and on and on. Right? Now, if I say aldehyde, now this is called as R. I just represent it like R. This is general representation. R can be any alkyl group. It can be methyl, ethyl, propyl, butyl, whatever it is. So any alkyl group with this tag on it, this CHO, cho, pyar se, huh? Okay, cho group on it, which is called as your aldehyde. CHO group, aldehyde. Now, the suffix for it is al. We say it as al. Chalo, now N equals to 1. 1 carbon CHO. 1 carbon CHO. The rest of it has to be hydrogen. Now, this is written as HCHO because I have to represent it the way where I should show that CHO tag. The CHO tag should be predominantly shown there. Then you can say, it will be easy for you to identify that it is an aldehyde. So then N equals to 2, or what's the name of it? HCHO is called as 1 carbon. It is your meth, and it is methanal. It was methanol in the alcohol. Now it is methanal. It is methanal, which is aldehyde. Or methanal is your IUPAC naming. You remember IUPAC naming, which is International Union of Pure and Applied Chemistry. So according to that, the naming is methanal. But according to the general formulation, that is formaldehyde. Formaldehyde. Okay, so this is formaldehyde. Now, if I say N equals to 2, 2 carbons at a stretch, because that's what the catenation property says. For carbon, catenation properties connect each and every carbon, carbon to carbon to carbon to carbon. You have a long chain, and that is what is called as catenation property, right? So carbon is able to do that. So 2 carbons at a stretch, number one thing what you will do. And then it is aldehyde. So CHO group has to be there. Here it is CH3, CHO, right? So I will write the representation as CH3, single bond, CHO. Now, what do you name that? So CH3, CHO is 2 carbons, and 2 carbons is ethanal. Ethanal is your IUPAC naming, or the general naming is acetaldehyde. It is acetaldehyde. Similarly, I want you to try it up for your N equals to 3, 4. Pause it up and if you have tried, if not, I am showing you. So N equals to 3, 3 carbons, 1, 2, 3, 3 carbons, aldehyde is CHO group. See now, always you need not show that CH on the top only. You can always show it like this, C double bond O, and this is H. You can show it like this. It is also CHO group only, no problem with that showing. Okay, so and then this is 2 hydrogens and this is 3 hydrogens. This is nothing but C2H5. All these are 5 hydrogens there. So this is C2H5 single bond CHO, or you can simply write it as CH3, CH2, CHO. The CHO should be shown properly. And this is 3 carbons, which is Propanal. Okay, so this is propanal. You don't need to worry about your general formulation for it. So go with your IUPAC naming, that is fine. So this is propanal. And as we have done it for the alcohols, I have not shown any of this tag in the middle. Like for the alcohols, we have also shown it like this, right? This is propan to all. But for aldehyde, I cannot show it like this because CH double bond O, if I show in the middle, see what is it happened here? So the middle carbon has got 5 bonds. Na baba, na. 5 bonds carbon cannot have. Carbon can have only 4 bonds. So therefore, you cannot have the CHO group in the middle. So it will be propanal only. It can't be propan 2-al or it can be butan 2-al or something. It cannot be that way. So carbons will be either of the ends में ही आपको aldehyde मिलेगा. All right. So this is about your aldehydes. Then alcohols we have done, aldehydes we have done. Then you have carboxylic acids. Carboxylic acids. Carboxylic acids. So it is COOH group. It is RCOOH. Don't say COOH. This is my tip to remember things. Okay. COOH group. It is COOH group. RCOOH. R is any alkyl group. Just now, as I have shown you, any alkyl group. So this has to be shown there. And this is oic acid. Oic acid like methanoic acid, ethanoic acid, propanoic acid, butanoic acid. Chalo, let's go with it then. Number 1, carbon 1. If N equals to 1, 1 carbon, double bond O, OH I have shown, then this carbon is not still satisfied. Carbon has got only 3 bonds there, so 1 more has to be hydrogen there. So this is HCOOH. This would be your methanoic acid. Methanoic acid is your IUPAC naming. Or what else can we say on this? This is your formic acid. Formic acid. This is formic acid. That was formaldehyde. Aldehyde N equals to 1 is formaldehyde, right? So number 2, let's go with N equals to 2. 2 carbons at a stretch you draw. And then COOH I am going. Now this is CH3COOH, which is called as 2 carbons, ethanoic acid, or it is acetaldehyde. Acetaldehyde. Like formaldehyde, N equals to 1 aldehyde, formaldehyde, N equals to 2 aldehyde, acetaldehyde. Okay, so the same thing here it is. This is your acetaldehyde. It is written as CH3COOH. CH3COOH. Now go on with N equals to 3 there. N equals to 3. So 3 carbons at a stretch, COOH. You can either show it on the right side or on the left side also. N equals to 4. C1, 2, 3, 4. I can show it like this also, na? Here also it is fine. There also it is fine. So COOH here. This is propanoic acid. Propanoic acid. And what is this? CH3, CH2, COOH. What is all this? This is nothing but my C2H5 COOH or CH3 CH2 COOH also is fine. Anything is fine, bacha. Okay, you just have to know how to write it. That's it. A special orientation has to be written for every carbon. That's it. You're done. And this is your propanoic acid, and this is what your COOH here. 1, 2, 3, 4, 4 carbons it is. This is my butanoic acid, right? So it is C3H7, as you can see here. C3H7 COOH is your butanoic acid. So all these you can write pentanoic acid, hexanoic acids, etc. as well. All right. So now next, going on with the next functional group, your ketones. Let us talk about ketones here. Write down this ketones. Ketones, so double bond O से start होंगे. This is how it looks like. This is your base structure of a ketone. Like alcohol, if I say alcohol base structure, it is R with an OH group. R is any alkyl group with an OH group. And if I talk about aldehyde, aldehyde is R with a CHO group. And if I talk about carboxylic carboxylic acid, it is R with COOH group, COOH group, right? And if I talk about ketone, this is the base structure. As you can see, double bond O se start karo, and then with a carbon here and right and left, both the sides you put the carbons there, right? This is your ketone. All right. Now talking about, let us say n equals to 1. Chalo, if I say n equals to 1, now one more thing. What will be the general formula for it? It is CnH2nO. CnH2nO is the general formula. So, but let us see. So, n equals to 1, if I take, it is one carbon, it is H2 and O, CH2O, it has to be, let us check out for that also, double bond O, carbon I have given, always start, ketone starts with this double bond O, say start karo, give it a carbon, right side one carbon, left side one carbon, both the sides, you have to have one, each carbon, so that's your main tag. And after that, you can extend your tags. Now, as you can see here, C double bond O given to you here, and it is only one carbon I asked, so definitely right side 1H and left side 1H. Do you notice this as a CHO group? It is not the ketone group, right? So it is ketone. No, it is aldehyde. Okay, so N equals to 1, not possible for ketone. Let's check if N equals to 2 is possible for ketone. You have two carbons. Now, always start with double bond O and one more carbon I have given, because two carbons, I have shown one more catenation property, kada, right? So I have shown that. So you have three hydrogens here, 1, 2, 3 here, and C double bond O here, and it has to be my hydrogen only, right? This carbon should be filled with all the 4 bonds there. So the rest of the bonds to be given by hydrogen. And this again is my CHO group. So N equals to 2 also does not exist. CHO group is an aldehyde group, and it is ethanal. Ethanal, what is this? This is my methanal. This is ethanal. It is not ketone. So your ketone starts from 3 only, right? So now you fill it up. Now this is CH3, CO, CH3, CH3, CO, CH3. This is ketone, and this is propanone. Propanone is the name for it. One is the tag for it. One. Okay, that is propanone. Then you have 4 carbons. Let us say 4 carbons. Oxygen, carbon here, and carbon here. 3 carbons, totally 4 carbons I want. Chalo, let me put a 4th carbon also here. Now, what is this called as? This is my butanone. I just have to fill the carbons here. This would be my butanone. And then you have pentanone, hexanone, all these kind of things you can go with, right? I'm just trying to show you some more on this, ketones only, right? You have a double bond O se start karo, 1 carbon on the right, 1 carbon on the left, 3 carbons done. If I have to show 5 carbons, I can show another 2 here, or I can show, so this is the 3 carbon structure. Then if I have to show 5 carbons, I can show 1 on the left or 1 on the right also. But what is the name? When you calculate the molecular formula, it's going to be the same. But what's the name of this? This is your ketone, 1, 2, 3, 4, 5, pentan 2-one, that is, because this is 1, 2, 3, 4, 5th carbon. Now you go forward or backward, anywhere you go, 1, 2, 3, 4, 5. Now on the 3rd position, you have, this is pentan 3-one, this is, right? So this is how you can write down pentanone or hexanone, heptanone, like this you can go. So this is your ketone. Now, do you observe one thing? For ketone and for your aldehyde, you have the same molecular formula. Have you observed that? CnH2nO is the molecular formula for your ketone and for your aldehydes as well, as you can see here. So this is what you have learned till now. Okay, so alkanes, alkenes, alkynes, alcohols, aldehydes, carboxylics, and ketones. So as you notice, Aldehydes and ketones. Do you notice this part? Aldehydes and ketones have got the same molecular formula, CnH2NO, CnH2NO, but the structure differs, right? Aldehyde structure is CHO group. Ketone structure is C double bond O, R and R dash on the other side. R dash is any other alkyl group. It can be same alkyl group, also any other alkyl group. That would be fine. So all these are your things, and you have something called as substitutions, which is a fluoro, chloro, bromo, iodo. So these are all the substitutions, and NO2 is nitro substitutions. Depending on the questions what you get, we can do the questions there on that. All right. So now all these are your compounds what you have. Now let us talk about something called as homologous series. Homologous series. Now, what do you mean by homologous series? Now, if I talk about chalo alkenes, let us write down alkenes. Alkenes, the first alkene is C2. Alkene starts from 2 onwards. C2H4, then C3H. Alkene is CnH2n only, right? So it would be C3H6, then C4H8, then C5H10, then C6H12. It goes on. So what is the pattern that you see here? So as you can notice some pattern, C2H4, the difference is 1 carbon and 2 hydrogen. And from there to here, the difference is 1 carbon, 2 hydrogen again. Next difference is again 1 carbon, 2 hydrogen, 1 carbon, 2 hydrogen. So each and every member, so all these series, this is called as homologous series. And each and every member of the group of this series differ by a CH group, which is a mass of 14U. Atomic mass unit, right? It is 14U. Why? Because carbon goes with 14 and each hydrogen goes with 1 each. So 2 hydrogens you have there. So 2. This is 12 plus 2. That is your 14 atomic mass. So they differ by a mass of 14. This is what is called as homologous series. Now, if I talk about alcohols also, 1 carbon, it is CH3OH. Then 2 carbons, it is C2H5OH. 3 carbons, it is C3H7OH. Then 4, C4H9OH. As you go on, one after the other in the series of alcohols, you get this series. This is also homologous series, wherein each and every member of the family, as you can see, they differ by a CH2 group. As they differ by a CH2 group, they go with 14U difference. They go with a difference of 14U, which is 14, right? Because why? Carbon is 14, carbon is 12 and hydrogen is 2. It will be your 12 plus 2, it will be 14. So 14 atomic mass difference you find there. All right. So this is about your homologous series. Now going on with your most important compounds of this chapter, the reactions of this chapter, which has been deleted to you. But please, I would urge you not to delete. Why? Because most of it is so much of important. The main things, what you do in your organic chemistry is here onwards. Till here, what you have done is all naming the compounds. You were just naming the compounds. Now let us play with these compounds, right? Let us now enjoy the essence of organic right now here with you now. Okay, now let me talk about first set of reactions there is called as combustion reactions. What do you mean by combustion? So what do you mean by combustion, bache? Combustion is anything like burning in the presence of oxygen. That is combustion, right? So burning what? Burning hydrocarbons. We are talking about hydrocarbons here. You're burning hydrocarbons in the presence of oxygen. That is called as combustion. Whichever you take, just I want you to practice at home on this. Let me take alkanes. Chalo, let's take first alkanes. So that would be propane, let us take. So C3 will be H, how much? Ane, alkane I am talking about. This is propane. Propane, 3 carbons and hydrogens will be double plus 2. Ane ante double plus 2. Double plus 2 is 8. Plus oxygen. And any hydrocarbon, any damn hydrocarbon you take and you burn it in the presence of oxygen, you are always getting CO2 plus H2O only. That's, remember that. Any hydrocarbon plus oxygen you do, whichever of the chapter, same chapter, whichever of the compounds you take, it's the only elements, only compounds you're going to get is CO2 plus H2O. Yes, here the trick lies in balancing things. That's it. So my product is CO2 plus H2O only, plus heat, plus light also, okay? Because these are exothermic, combustion is exothermic reaction, plus heat, plus light. If it is burning, obviously it gives out light, right? So now how do we balance this? There is a trick to follow. First of all, like whenever you have a pure element here, you can see this oxygen, okay? Pure element is oxygen. Now, as you see, as you can see here, once we have written this, you have to always balance again. I said balancing, whenever you have a pure element, you will balance this pure element at the end. So you have three carbons here, other than oxygen and hydrogen, whatever you will balance it. So you have carbons, you have three carbons there, put a 3 in front of it. So carbon is done, balanced. Hydrogens, you have 8 of them, put a 4 in front, 4 twos are 8, done. How many oxygens do we have? So oxygen here is 3 twos are 6 plus 4, which is 10 oxygens I have. So I'm putting a 5. That's it, done. So similarly, if I have propanal, okay, propanal. Propanal would be what? My 1, 2, 3. And then al is aldehyde, which is CHO, right? So now write it down, C3 H, how many H? 1, 2, 3, 4, 5, right? So, which is C3H6O. C3H6O plus O2 will give me what? Will give me CO2 plus H2O only. They don't need to tell you what is that giving you. It has to be CO2 plus H2O only, because any hydrocarbon you take, you are going to get CO2 plus H2 only. You have three carbons here, put a 3 in front of it. Hydrogen 6 you have, put a 3 in front of it. How many oxygens? 3 twos are 6, 6 plus 3, 9 oxygens you have, out of which 1 is here. So you want 8 more. So put a 4 in front of this. So it is done, propanal. So like this, I want you to try at least for 5 to 6 or 10 hydrocarbons. Take any 10 hydrocarbons of your choice, propanal, butanoic acid, or pentanoic acid, whichever it is. You take them and do the combustion. So combustion always yields you CO2 plus H2O plus heat plus light only, nothing else. And then you have C plus O2 will give you CO2. This you have been doing from since ages now. So don't worry about that part. So now combustion reaction, I hope it is clear to you all. Now let us talk about the next coming up reactions. For the main things, what you have here is, bacha, you have two compounds to talk about mainly. One alcohol, ethanol there, and the other ethanoic acid, which is your ethanoic acid. As you can see, this is your carboxylic acid. The very two important compounds for you, for your 10th graders, which it has been deleted or not deleted. I don't care, because I don't even look at what the deleted syllabus is, because everything is important. But this is so very important. So please try to learn things as the concept well. All right. So these are the only two compounds. You have ethanol and you have ethanoic acid. Let us come to the ethanoic acid part later. Let us first finish up with the ethanol. So all this is ethanol. What are the physical properties? Please write down your notes clearly on this. Okay. Pure ethanol is colorless liquid, as you can see here, colorless liquid, specific smell and burning taste. Alcohol it is, so it has got that burning things in your throat when intaken, and soluble in water. It is miscible liquid. It is miscible, which means it can get mixed up with water very easily, and its boiling point is 351 Kelvin, which is higher than its corresponding alkanes. Higher boiling point it has got. And uses, it is present in alcoholic beverages such as beer, wine, whiskey, and then it is used as antiseptic for sterilizing wounds, then cough syrups and all, and the digestive syrups, tonics, everywhere wherein sedatives are used and all, like cough syrups. Alcohol is, Benadryl is a cough syrup wherein alcohol, ethanol is used, because it has to give that sedative thing, because your body is tired. Your body is tired because of coughing and all, then you need some kind of sedatives to soothe your body, to make your body rest, then then a small dosage of alcohol along with the other drugs is present there. So therefore, alcohol is present in cough syrups. Then ethanol is being mixed with petrol and it is used as a motor fuel, as you can see here. Then the mixture is called as power alcohol. Power. You must have seen this in the petrol pumps, right? Gas stations, wherein you have petrol and power petrol. You have two things also. Power petrol is a little costlier, but I don't find so much of a usage for that right now on these roads for us. So yeah, it is fine. So petrol, ethanol is being mixed with petrol, then it is used as a motor fuel, which is power alcohol or power petrols, what you can see. So depending on the amount of this, okay. Then mixture of ethanol and water has lower freezing point than water, lower freezing point. This mixture is known as antifreeze and it is used as in radiators in cold countries. Antifreeze. It has got that lower freezing point. So the freezing point lowers, which means that at extremely low conditions only, this can get frozen. Otherwise, we can use that. So that's the reason it is used as radiators in the vehicles. So that the cold countries, in those chilled countries, because of that low temperatures, what happens? Everything gets freezes up. So here is an antifreeze technology for this. That's the reason. Then ethanol is used for preparation of chloroform, iodoform, ethanoic acid, and all these things. Okay, ethyl ethanoate, and this is nothing but your soap. Oh, we will talk about this later here only. Next. Then your ethyl alcohol is used as hypotonic solution, hypotonic, which includes the sleep, which, as I told, which is used as sedatives. So these are all the uses, right? Then coming up with chemical properties. Chemical properties, as you can see, dehydration. Ethanol has got the property of dehydrating the body. That's the reason the drug, the alcoholic people, they get fainted or something because of the alcoholic effect on their cerebellum. Cerebellum actually is responsible for the balance of the body, and so cerebellum gets affected. So therefore, your balance gets disturbed, and moreover, it dehydrates the body. So the people are advised to have more and more water, more and more fluids, as they have a lot of intake of alcohols. So dehydration, ethanol when heated with concentrated sulfuric acid will show dehydration reactions. So it is nothing but ethanol, right? It is two carbons with OH, as I can show you like this here. Here is my ethanol, right? In the presence of concentrated H2SO4. Very, very, very important. Okay, here OH goes out. Okay, this is OH and hydrogen goes out. So hydrogen and OH, which means water molecule comes out. Then what am I left out with? I will be left out with, here, see, water comes out. Then I am left out with two carbons and four hydrogens. Do you notice this part here? I'm left out with two carbons and four hydrogens. C2H4 I am left out with. How do I draw C2H4? Two carbons as it is, four hydrogens, two here and two here. This is what I can show. But my carbon is not satisfied. Carbon is having only three bonds, but carbon should have four bonds. This is how I write. Now this is double bond. Ene. Hey, it is ene. So this is ethene. Ethene. That is what we got. CH2, CH2. Ethene is what we got here. So this is the first reaction, dehydration, the most important, most widely used, widely asked in the public examinations, right? And very, very important if it is deleted for you, but still I want you to learn them, bacha, because you're learning chemistry. As you should have the feel of chemistry and you should understand chemistry, where your applications are. That will give you the essence of chemistry there, the uses and all. So don't go on to any of the deleted syllabus. We are not going to delete anything from the syllabus. All right. Next, hitting on to the next one, reaction with sodium. Now, sodium is what? Sodium is a metal, right? And it's a reactive metal. C2H5OH again. This is alcohol again. 1, 2, 2, and alcohol. This is what your alcohol is, CH2OH. Now, sodium is a metal. We have already seen in the displacement reactions, like simple displacement reaction. What do you mean by that? Metal displaces hydrogen. So it is sodium. It's a very, very reactive metal. It attacks on this hydrogen, displaces from its position. And then what is going to happen there? 2 carbon with ONA. 2 carbon, the rest of all are there, which means C2H5ONA. This is sodium ethoxide. Bacha, when remember one, these nomenclatures are very important. When OH of your alcohol, in that OH, if H is replaced by your metal, then it is oxide, ethoxide, sodium ethoxide. Okay, so which is metal alkoxide is the general nomenclature. Metal alkoxide. If it is sodium metal, it is sodium ethoxide alkane, which is your eth there. So it is sodium ethoxide. Or if it is any other metal, potassium, and you have your propanol there. So that would be potassium propoxide. So depending on that, you will write metal alkoxide is the name. But you don't understand it, you pause it, go back, listen to me again, and then come back to me. Still you don't understand it, please do let me know in the next class when I see you. All right. Please note them down. But okay, I want you to note them down as a list. I want every list of the reaction here. And then what happens is hydrogen got displaced. So hydrogen is being released there. And that is what is called as sodium ethoxide. Next, you have oxidation. Yeah, this oxidation is also a beautiful thing. Okay, I'll show you one thing here. So oxidation reactions, not just one oxidation reaction I'm going to show you. I'm going to show you many oxidation reactions here. Yeah, I'll show you one thing here. So remember one thing, what is that we have learned till now? Till now, we have learned in a row, let us write down, right? We have written first alkane, then alkene, then alkyne, then alcohol, then please write it down exactly like what I'm writing, yeah? Alcohol, then aldehyde, then carboxylic, right? I'm not writing ketone. Why? Because ketone and aldehydes, they share the same formula. Aldehyde ke niche, ketone, I would say. Ketone will not get transformed into carboxylic, whereas aldehyde does get transformed into carboxylic by oxidation. Single O, this is called as nascent oxygen, which means it is oxidation going on. And oxidation is what? Gain or loss of electrons is what called as oxidation. And what are the agents for oxidation? Agents, very important agents. What you have to write is alkaline KMnO4, alkaline KMnO4, potassium permanganate, or acidified K2Cr2O7, acidified potassium dichromate, or alkaline KMnO4. These are your oxidizing agents. These are. So whenever you see one of these things, you will definitely go attack on this one after the other. It's like a chain. It's like a train journey, right? The alkane to alkene, alkene to alkyne, alkyne to alcohol. You just go on, and the final end point is your carboxylic acid. That's your destination. That's your terminal point. Okay. So now, if I do oxidation on alkane, you would get alkene, then alkyne. It goes on like that, right? And when you come back, when you do reduction, so reduction is you turn back and come back. So this is reduction, and then the reducing agent is concentrated H2SO4. It's a very good reducing agent also, and a drying agent as well, right? So it's a good drying agent and also a very good reducing agent. So from the carboxylic, if you have to come back, from the carboxylic, you will get aldehyde, then alcohol, then alkyne, then alkene, then alkane. So that's the backward you go, then it is reduction process. And reduction ke liye you have best reducing agents. Reducing agent is concentrated sulfuric acid. Oxidizing agent ke liye alkaline KMnO4 or acidified K2Cr2O7. Clear? Now, there is a small trick here. You focus on alcohol. Okay. So here is my alcohol, right? So from alcohol, if I do oxidation, I should be getting aldehyde, right? Yes. So from alcohol, if I do oxidation, I get aldehyde, but aldehyde so produced is so very, unstable. So it directly goes on to carboxylic. So there is no two steps here. It is two-step reaction, but we will be showing it for your class 10 as only one step there. It is carboxylic acid because aldehyde is prepared. Yes, but as long as aldehyde is prepared, it immediately shifts to the carboxylic. It immediately oxidizes to carboxylic acid, right? So then you have similarly, this happens with alcohol because alcohol is very stable there. So then you have aldehyde, which is not so stable. So hence it moves on to the carboxylic. Now I come back on the reduction. Reduction on alcohol has to turn to your alkyne and then to alkene, right? But it is a direct again, alcohol to alkene. This is reduction. We have just now seen that reaction, right? Alcohol, ethanol plus your alcohol plus your concentrated H2SO4 will remove water there, dehydrating agent. Your water is removed, then your alkene is produced. So one skip, alcohol के लिए एक skip करो. Whether you go forward or go backward, just skip one. Okay. So alcohol to carboxylic, you get oxidation. Then alcohol to alkene, you get as reduction. This tip, if you remember, you will go with the answers very like this on the fingertips there. All right. So this is your oxidation and reduction. Now going back to your page here as I can show you. Now tell me oxidation with alkaline KMNO4. As you can see here, oxidation with alkaline KMNO4. Alkaline KMNO4 देखा तो it is an oxidizing agent. Oxidizing agent alcohol पे oxidation किया तो aldehyde मिलना चाहिए. But carboxylic milega, right? Because it is unstable, it moves on further, carboxylic. You have 2 carbon aldehyde alcohol, so 2 carbon alcohol, ethanoic acid milega, 2 carbon with carboxylic. Carboxylic is C double bond OH, right? Now this is CH3. So you don't need to worry about the formula. Just remember it is a carboxylic acid. If it is a carboxylic acid, it has to be COOH group. So I have seen this COOH group here. Now this is CH3COOH. This is what you get, right? So this is exactly what is written here, right? If you remember the tagline of ethanoic acid or any alcohol, your oic acids there, it is COOH is your oic acid. So your oic acid is produced, right? Oic acid is produced, 2 carbon ka liya aapne, to 2 carbon hi milega aapko. That is how you can go there, right? Although these reactions will not go this way, the main reason for the reactions, you will be knowing it furthermore in your next coming up grades. But for here, for you to remember, I'm giving you these tips, bacha. All right, Next, coming up with oxidation with acidified potassium dichromate, also the same thing, which is the same thing produced there. You're going to get alcohol, your ethanoic acid, right? So then you can see those color change reactions also. K2Cr2O7 changes to green color and all. You can just remember those color change. I'm not emphasizing much on that. Then you have very important esterification. What do you mean by esterification? Esters are nothing but this is an ester. Okay, this is called as an ester. Ester is nothing but the sweet smelling agents in your perfumes. Those are called as ester. These are the sweet smelling agents like jasmine smell. What you get, the fragrance, what you get is not exactly the jasmine all the time. It is more of your chemicals, right? So all these sweet smelling agents in your perfumes, in your soaps, or we call these esters. Now the only 2 compounds what you have for your compound, for your questions, for your chapters is alcohol and ethanol and ethanoic acid. Go with the reaction with both of them. Ethanoic acid is nothing but 2 carbon C double bond OH plus ethanol is 2 carbon OH alcohol, right? So what will you do now? You have to make up a reaction with them. Now it is from your this and this, you remove these 2. What is happening here? H2O, water gets removed. Is that clear? Water gets removed and then just join them. As you join them, how do you join them? See, check out how am I joining? See, C double bond O there and then this part, then single bond O, and then two carbons. This is what it is. I'm joining this dabba, I'm joining here. So which means this group, as you can see, double bond O with single bond O there, it is nothing but your alkyl alkanoate. Alkyl alkanoate. Here it is ethyl ethanoate because you have eth only. You have prop eth, that is propyl ethanoate and all you get. That's how you can just interpret them. So now this is the structure. Now always whenever you do the organic chemistry, focus on your structure. C double bond O, then two carbons there. All right, two carbons is, you can just open up your hydrogens. I'm not writing the hydrogens anymore now onwards, right? I hope you understand how many hydrogens are there. Each high carbon has to be filled with 4 bonds. The remaining bonds are hydrogens. That's it. So this is ethyl ethanoate. This is the ester. This is the sweet smell that you get in ice creams, cold drinks, perfumes, all these things. The fruity smell, what you get is out of this. So all these are chemicals. Please don't go for them. All right. Yes, moving on. And what does this do in the presence of concentrated sulfuric acid? What does that do? This is the one which is the dehydrating agent. Concentrated sulfuric acid, wherever you see, it's a dehydrating agent. It will remove water from its position, right? So that is what is called as esterification, because you're making ester out of the only two compounds what you have for your syllabus, ethanol and ethanoic acid. Now an interesting thing here is your saponification. I hope it is not given here, but we will do that as it comes on the next page. It is there in the next page. I'll show you to the next page to you. Next, combustion, we have already seen this, right? So these are the reactions of ethanol, your chemical properties, which are being shown by your ethanol, your physical properties, the uses, right? Now let us come up with your ethanoic acid. Ethanoic acid. These are the only two compounds what you have, bacha. Okay, this is ethanoic acid we are talking about. Ethanoic acid, as you can see, vinegar. Okay, vinegar has got this ethanoic acid in it, right? The most diluted version of ethanoic acid is nothing but your vinegar used in this, noodles and all the Chinese foodstuffs, or in preservatives. All these things we will be seeing them as well there. Okay, whereas the lower carboxylic acids are the liquids, whereas the higher ones are the solids. So any of these organic substances, what you see, the lower ones, which means number of carbons less, like you have 2 carbons, 3 carbons, 4 carbons, that's still that. Okay, and then next onwards, 5 carbons, 6 carbons, 7 carbons as you have, that will build up with your solids and all. Then you have ethanoic acid. Acids hai to sour in taste rahega. Other lower carboxylic acids are also sour in taste, and their boiling point is 391 Kelvin, and this is nothing to explain, right? I get you should remember that, yes. The boiling point is 391 Kelvin, and they have higher boiling points as corresponding to their alcohols and aldehydes because of the hydrogen bonding what they undergo. So, and also the van der Waals forces, which we do not have right now. So as it comes, I will be teaching you that forces as well. Next, coming up with acetic acid, or nothing but your ethanoic acid. Acetic acid is a general name for your ethanoic acid, right? Is soluble in water and it is miscible. Miscible is it can just mix up with water in all proportions. And lower carboxylic acids are soluble. Lower organic matter is soluble, but the higher ones are not soluble. Bacha. Then acetic acid freezes at 290 Kelvin. Thus, in cold weather, the acetic acid may, turn into the freezing, mode, which is called as glacial acetic acid also. That's the reason it is called as glacial acetic acid. So it is it generally turns into that freezing mode. Then you have uses for making vinegar, laboratory reagents that is used in a lot of, compounds, lot of reagents, used in. Then preparation of white lead, which is used in white paints, in the paint. You don't need to remember this right now. So you can remember this, but white lead, it is called as used in white paints. And coagulation of rubber from the season and from the milk as well, for the rubber, to get that rubber texture, that, that hard texture, what you get, that is from that liquid, you use this. And Preparation of acetone. Acetone is nothing but your propanone. Propanone is acetone, bacha. Double bond O, carbon here. Propanone is ketone. Remember that. Prop is 3 carbons, one on the right, one on the left. That is your base structure. This is propanone. This is CH3, C double bond O, CH3 acetone. And any of the aspirin used in medicines. Aspirin is nothing but your blood thinners. It thins the blood. Okay, so such kind of medication and all is using this ethanoic acid, and cellulose and all is being prepared also. Then used in artificial flavors, perfumes, then bacteria, all these things. You can just note these uses there. Okay, used in dyeing industry, waterproofing and all these. So now these are the uses. Now coming up with your chemical properties. But if I'm going a little faster, please pause it, then go back and then you do. All right. Next, coming up with ethanoic acid is a weak acid, but it turns blue litmus red. Acid hai to red में turn hoga. It is weak acid, but it turns. Okay. Then reaction with metals, as it is metal. Metal have the tendency to displace hydrogen. So here is the hydrogen displaced. Here is the hydrogen displaced. So here comes up with CH3COO minus and Na plus kada. It is CH3COO minus and Na plus is sodium ethanoate. There it was ethoxide, sodium ethoxide. When alcohol is being replaced by metal, that is called as sodium ethoxide. This is sodium ethanoate. Please try to relate those things. Okay. Then with zinc, see, it is CH3COO minus and this is Zn plus 2, right? When you crisscross it, this is nothing but CH3COO twice and then Zn ke niche 1 aa jayega. This is zinc ethanoate, that is sodium ethanoate. So I hope you get that terminologies well. Okay, when alcohol is substituted with a metal, it is called as alkoxide. When when your oic acid, when your carboxylic acid is replaced, hydrogen is replaced with your sodium metal or any other metal, it is called as alkanoate, metal alkanoate. Okay, next reaction with carbonates and bicarbonates. Now, we didn't see any reaction with carbonates and bicarbonates for alcohols. Why? That is a distinguishing test, you can say also. Why? Because any carbonates are basic in nature. Alcohol is basic in nature. So basic and basic in nature, they form a mixture. They don't show any reaction, right? So that's the important distinguishing test between, you're given two test tubes and you're asked, you are given two test tubes and you're asked which one is alcohol, which one is your carboxylic acid. Then what we will do? We will put some carbonate or bicarbonate salts in it. Then if reaction happens, it is acid. Why? Because carbonates are basic in nature. Remember, these are basic in nature. And basic in nature, ethanoic acid, as the name says, it is acid, acidic in nature. Although it is mild acid, it is acidic in nature. So acid and base turns out to be your salt and water. And salt and water is neutralization reaction, that is. So ethanoic acid with this. Any carbonates will be giving me carbon dioxide. That's what one tip, what we generally go with, right? Whatever carbonate you take, you get carbon dioxide. Salt and water you will get. Now what is that happening? You are going to get sodium getting displaced on this. Any, the same thing as the metal displacement you can see there, right? CH3COO Na, the same thing you get, right? CH3COO minus, right? This is CH3COO minus and H plus, because it is an acid displaces hydrogen plus ion. So H plus ion comes out, CH3COO minus left out and Na plus. Khatam kahani, right? And similarly, bicarbonate also will give you carbon dioxide, will also give you this, that is also basic in nature. Then it is going to give the same thing, but balancing differs. That's it, Rishabh. The difference between these two things is just in balancing. And this is the distinguishing factor to identify whether your given compound is your alcohol or carboxylic acid. Remember that. Next, coming up with reaction with base. Yes, reaction with base happens here. Okay, so why? Because this is a base, acid, so it happens, whereas reaction with base does not come with alcohol. Alcohol plus base, we don't see any reaction. That is one more distinguishing test, whether you get an alcohol or aldehyde there. So it is acid plus base is salt and water. Salt, this is COO minus and this is H plus. All this is minus here, I would write. and that would be H plus there, right? All this is minus and that is plus, and this is Na plus and OH minus. OH minus goes with H plus, there comes out to be your water, and then you're left out with CH3COO-Na. So this is sodium ethanoate. Again, this is nothing but your soap, bacha. It is soap. Okay, sodium ethanoate. The soap, what you see is sodium ethanoate. What you use daily is sodium ethanoate. Then you have decarboxylation is nothing but removing carbon, right? Removing carbon is nothing but decarboxylation. Soda lime is called as NaOH and CH3COO-Na. You can see this Na2CO3 going off. You can see this part. Yes. This is Na2CO3 going off. Okay. Signing off Na2CO3. Come on out. Then you have CH3 and one hydrogen. It is nothing but your CH4, right? So this is your, as you heat it, your soda lime and sodium ethanoate. This is salt of ethanoic acid and sodium ethanoate. This is 3:1 parts. It will give you methane gas. And this is called as decarboxylation because carbon dioxide is being removed. Na2CO3 removes your carbon dioxide there. Then reaction with alcohols. As we have just now seen there also, right? Alcohol with with your ethanoic acid. So don't, confuse yourself there. Acid है तो H plus निकलेगा, but here please remove OH and here remove H because this is the reaction which you don't know the mechanism for. So mechanisms are taught to you in your grade 11. So when we do that, you will understand that. But for now, you remember that water molecule comes out. That's it. And then just attach them. That's it. As we have done it previously, the same reaction it is. Reaction with alcohols. Then you have here what is showing here. This is your reduction, and reduction is LiAlH4 is the reducing agent, or you can use concentrated H2SO4. But here we don't use concentrated H2SO4 because it is acid and acid that may end up with your mixture there. So that's the reason we are not using that. Yes, we can use it, but for a given temperature. So best reducing agent here is LiAlH4, lithium aluminium hydride. This is the best reducing agent. Lithium aluminium hydride it is. It supplies hydrides. As it supplies hydrides, and then OH minus and all these comes out. Then as it is oic acid, reduction आपका गाड़ी पीछे जाना चाहिए. So carboxylic से aldehyde, then aldehyde से alcohol पे आके रुक गया गाड़ी, देखा? So यहाँ से पहले you got your ethanol, but you're not stopping there because it's a very strong oxidizing agent. You would skip one, as we have seen in the oxidation and reduction reactions. You go back and check up with that. So you would see that oxidation reduction reactions, reduction on carboxylic will be showing you your alcohol, right? So this is your reactions here shown for your alcohols, and this as well. Yeah, as you can see here, this one, but I'm showing you, I'm talking about reduction, go back. Reduction on carboxylic, you go back to alcohols. So these are your reactions. Now, then we have seen one ester, right? So esters, as we have seen, yeah, this esterification when hydrolysis on esters, hydrolysis. Now this is a reversible reaction. This reaction, as you can see, the reversible reaction for this reaction is, this is called as hydrolysis. Hydrolysis of esters in the presence of NaOH. Hydrolysis of esters in the presence of NaOH will give me what? Will give me back the ethanoic acid and ethanol. Yes, ethanol, yes, C2H5OH you get, plus ethanoic acid, ethanoic salt you get, because ethanoic acids are very, unstable. So very, very unreactive, I would say. So therefore it is CH3COO-Na I get. This is sodium ethanoate. This is my salt of that, nothing but soap. So here this reaction A and reaction B together are called as saponification. Saponification, which means preparation of soap. right? That is what called as saponification. The first one is esterification, because ethyl ethanoate is nothing but your ester, which is your sweet smelling agent in your soaps. That is ester, that is called as esterification. The other thing is your saponification. So these are the two very, very, very important compounds on which we had a detailed conversation, detailed physical characteristics, their uses, and their chemical characteristics, chemical reactions done. Now the last topic for the day. It is your soap and detergent. What is soap and what is detergent? Or I would say first, let us talk about the cleansing action of the soap, because we are talking about soaps and all. Let us see how the cleansing action of the soap happens. Like I have some dirt. Okay, this is my handkerchief. Okay, this is my handkerchief and I have some dirt on it. And dirt is oily in nature. Dirt is always oily. Dirt, oily in nature. So now I am putting in some detergent in it or some soap in it, right? As I put some soap in it, like you eat food, na? As you eat food, you have to wash heavy food and all. As you eat, you will wash your hands with soap. Only then this greasy texture will go off, right? So why is this greasy texture going off as you are as you use the soap? Why? Because this is how we are going to see that. See, I'm putting some soap. Soap is what? CH3COO-Na. We have just now seen. Okay. This is sodium ethanoate is the soap there. Now this is minus and this is plus, right? This is a salt, right? This is sodium ethanoate. This is my sodium salt. Now what is happening? Check out. Now as all this is happening in a bucket of water, right? In a tank full of water, right? Now as I put salt in water, salt ionizes. That's what happens. NaCl, or whatever salt you put in water, it gets splits up into Na plus Cl minus. Similarly, CH3COO-Na also splits itself into CH3COO minus and Na plus. Now, as this part is called as hydrophobic part. Okay, the carboxylic end. This is called as the carboxylic end. And Na plus is hydrophilic. Please write this clearly. Okay, hydrophilic part. Okay. Anything hydrophile. Phile is electron, is the lover of it. Na plus wants to be with water. Hydro is with water. Hydrophobic, which means phobia towards water. I don't want to be with water. That is phobia towards water. CH3COO minus is phobia for water. It does not want to be with water, right? So whenever there is this dirt here, as this is my handkerchief with all this dirt, now these salt particles, all these get radially attached in this way. All the positive parts towards the against the dirt, and all the negatives towards the dirt. Negative ions. All these negative ions towards the oily part. Why? Because the negative ions, which is your carboxylic end of it is hydrophobic part. Hydrophobia, phobia is you don't want to be with water. I have fear for water. I don't want to be with water. So therefore, it is the hydrophobic part which does not want to be with water. Hence, it wants to be with the oil only. Then the sodium part is hydrophilic part. It wants to be with water. So all the plus ions are getting arranged like this. So this kind of radial arrangement, this is a radial arrangement shown there. Radial arrangement of all these ions in this pattern is called as missile. Okay, these are called as this formation is called as missile formation. Now once these are arranged in this manner, you as it is shown in the ads, it is not like from here you bring it up and you say, oh my god, ye saaf ho gaya. Aisa to nahi hoga, right? You have to agitate it, right? As you agitate your cloth, okay, the dirty cloth, as you agitate the dirty cloth in the water, what happens? All these ions get disturbed. They are no more in that position. They get disturbed. As they get disturbed, what happens here? as they get disturbed, these negative particles, they do not want to be with water. We have just now seen that they are phobic towards water. They have phobia towards water. They don't want to be with water. So they want to be with oil, right? So as they get disturbed, they want to be with oil. So they bring back the oil from the cloth as they are getting disturbed. They get displaced from that position, bringing that oil content along with them because they don't want to be with water. So that's the reason your cloth becomes dirt free, right? So all that dirt has come out of the water, all that oily content has come out of the water. As you wash your hands also, the greasy hands with soap, the same thing happens. All that dirt particle is your oily particle will come out with the carboxylic part. And then your Na plus remains in the water. So that is how it forms. Like all this is a bucket of water, I say, all this is water content there. So here what is happening? All the dirt particles has come out and they are moving there only. All this is now a colloidal solution. Colloidal solution of dirt, right? So all this, your mud water you get there, your muddy water you get left out there. So your cloth gets cleaned up, and that is what is called as the cleansing action of the soap. This is one important point. The radial arrangement is called as micelle, and this micelle formation, as it is formed, once you agitate it, all the negative phobic end comes out along with the dirt. Thereby your cloth is dirt free. And this solution, what is left behind is the colloidal solution. Colloids are what? Nothing but these particles are moving in the zigzag patterns. They move in the zigzag patterns all around in the lattice, which is called as the Brownian movement, which is exhibited by the colloidal substances. And also it shows the Tyndall effect also. Tyndall, because it scatters the light, no? Tyndall effect it shows, and also shows the Brownian movement. Brownian movement is also observed there, right? So this is about your cleansing action of the soap. Very important. Cleanse. I hope you understand now how your hands are cleaned as you use soap, right? Cleansing action of soap it is, right? Now coming up with the last topic of 5 minutes more. I'm sure you must be sitting here for a long time. Good. I appreciate your patience. One last now. This is soap, only 5 more minutes. It is soap and detergent. And what are the differences between them? Soap is made of carboxylic acid salts of carboxylic acids. And detergents are made up of salts of sulfonic acids. Sulfonic acid salts are very strong, very, very strong. And this is mild. Soap is mild. Sulfonic acid is very strong, whereas formed by detergents are formed of sulfonic acid salts, which are very strong, whereas soap is formed of carboxylic acid salts, which are mild. Okay. Now, as you use soap on hard, how do you differentiate which is soap and which is your detergent? Then you're given two buckets. It's one of hard water and soft water. Soap, what does it do? Soap leaves scum in hard water. Scum, as you see, scum, what is that scum? You see the traces, the white traces on your mories, on your drains as you use soap with your hard water. If it is groundwater, if it is not Manjeera line what we have, or it was not pure, the drinking water there, then if it is groundwater has got more of salts dissolved. And these salts, as you use, these salts, when it cannot get dissolved by soap, as because soap is mild, right? So these salts cannot get dissolved and they come out like in traces. That is called as scum. That white traces as you see on the drains as you go for a bath, that is your scum. If it is good water, it is not hard water. If it is soft water, then you will find foam there. Foam, you get the foam, na? That is foam. So it leaves scum in hard water. It leaves foam in both hard and soft waters. Hard and soft water. It leaves foam only. The detergent leave foam in both hard and soft water because it can dissolve. Detergent is made of sulfonic acid. It can dissolve your salts there. And soap can differentiate whether it is hard water or soft water. It leaves scum in hard water, leaves foam in soft water. Soft water. And what is hard water and what is soft water? Hard water has got much of dissolved salts in it, right? Soft water is not having so much of salts. There ends your topic, your carbon and its compounds. So I want you to go through every bit of it and please try to answer each and every question from your textbook. And do let me know if any other help I can do on this chapter. And each and every point has been discussed, nothing has been left out. So I want you to study this, make a good note of it, and then come back to me the next class. Okay, so for any other discussions on these and any other doubts which you have on this, let us discuss them in the class then. So for this, signing off, this is Harita Kasturi from PACE IIT and Medical, Hyderabad. Bye-bye, see you, take care, and happy learning to all of you.